Okay, in topic 4, we're going to look at writing fractions in order. And this is very, very similar to comparing fractions in the sense that as long as we have a common denominator, we can easily compare fractions by their numerator. The same thing goes for writing a series of fractions in order. As long as we have a common denominator, we can order the fractions based on their numerators. Okay, so that's going to be the exact same process that we're going to do here. So we need to first find an LCD. Two, find equivalent forms of each of the fraction. And then three, put the fractions in order based on their numerators. Okay, so example 4 says put each list of fractions in order. And I didn't specifically say it, but you do want to go smallest to largest unless your directions tell you otherwise. So we're going to go smallest to largest. Now, there are a few different ways that we can find LCDs. Okay, so we know two really easy ones where we list out multiples or where we do the prime factorizations. And example A, it looks like it would be pretty easy. We've got 1/3, 1/4, and 2/7. We could certainly list out multiples, but I'm going to do the prime factorization table here, even though two of our denominators are prime to begin with, and the table is going to be really simple. I think you'll see that this is a good example of when the prime factorization table is actually quicker, okay? So what we need is a row in our table for each denominator, and then we need a row for the LCD. Let me scoot that back a little bit. Now, I want to start listing out factors, and the only denominator here that has a factorization would be 4. 3 and 7 are both prime, so the only factors in 3 and 7 are 3 and then 7. But 4 I could write as 2 times 2, so I'm going to start by writing that out. Now, once I put a number in a column, that is the only kind of number that can go in that column. So these first two columns are twos columns. The only numbers that could go there would be twos. So when I look to fill in the factorization or something for 3, I'm going to have to start a new column. And then when I go to fill in 7, I've got a twos column, another twos column, a threes column. I need to start a brand new column for 7. So it's kind of a sad little table here. But remember, the number of columns tells you the number of factors in your LCD. So I have 2 times 2 times 3 times 7. So 2 times 2 is 4, 3 times 7 is 21, and 4 times 21 is 84. So this is our LCD. This would have taken us a long time if we were listing out multiples. So just imagine how many multiples of 3 you would have to list out until you got to 84. Think about how many multiples of 4 you would have to list out until you got to 84. You'd have to list out 21, even more than that for 3. So this is a really good example of when the prime factorization table is actually a lot quicker. And if you don't believe me, pause the video and list out multiples until you get to 84 for each of these three numbers. It's going to take a minute. Now what we want to do is we want to rewrite each fraction as an equivalent form using the denominator. Okay, so we have to ask ourselves if we're going to convert 1/3 into something out of 84, we need to figure out what we would multiply 3 by to get 84. And sometimes it's not super obvious, so if you need to do a little side work, you can. We need to know how many times 3 would go into 84. So we'll just do a little long division real quick. So let's see, 3 will go into 8 twice. 2 times 3 is 6. We want to subtract 6. That leaves us a 2. We drop down the 4. So 3 into 4, it goes 8 times. 8 times 3 is 24. I get a 0 remainder. So that tells me I would have to multiply 3 by 28 to get 84. Okay? So we're going to multiply top and bottom by 28. So we get 28 over 84. Okay? Now for the next fraction, we have 1/4. So I need to rewrite 1/4 as an equivalent form using 84 as the denominator. So we have to ask ourselves, what would we multiply 4 by to get 84? Well, hopefully you can see here we'd have to multiply it by 21. So I'm going to multiply top and bottom by 21. So that tells me 21/84 is equivalent to 1/4. And then finally, I need to do the same thing for 2/7. I need to rewrite 2/7 as something out of 84. Again, if you don't know how many times 7 goes into 84, you can do a little side work. 7 will go into 84. Let's see, 7 goes into 8 one time. 1 times 7 is 7. We subtract and we get a 1. We drop down the 4. 7 goes into 14 twice. 2 times 7 is 14, so you get your zero remainder. So that tells me I'd have to multiply 7 by 12 to get 84. So we want to multiply top and bottom by 12. So 2 times 12 is 24. So here's what we're really comparing. We need to compare 28 84ths, 21 84ths, and 24 84ths. So which one of these is the smallest? Well, all we have to do is compare the numerators. So of 28, 21, and 24, which is the smallest? That would be 21. Now, out of 24 and 28, which is the smallest? Well, 24. So that's going to be our second fraction. And then third, we would have 28 24ths. So let's put the original fractions in order based on 1, 2, and 3. So let me get rid of some side work here just to make it a little roomier. All right, so our final answer, the smallest of the fractions is 21 84ths, which lined up with 1/4. The next smallest was 24 84ths, which lines up with 2/7. And then the largest of the three fractions was 28 84ths, which was 1/3. So there you have the fractions in order, smallest to largest. So it's definitely a process finding the LCD and equivalent forms. It's not necessarily hard, but it takes some time, okay? So find your LCD, find your equivalent forms, and then order these numbers based on their numerators, okay? Let's do another one. And again, anytime you're dealing with negatives, you just have to be a little bit more careful, okay? So let's see, we've got 5, 8, and 10. Let's go ahead and list out multiples. In this case, it won't be so bad to list out multiples. So let's see. I'm going to do them in reverse order because I think if we do the biggest one first, we might get our answer a little bit quicker. So let's see, 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40. And I'm going to stop there because I feel like that's going to be our lucky number. But let's see. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And 8 times 5 is 40. So we've got 40 showing up twice. Let's see if we can get it as a multiple of 5. So 5 times 1 is 5, times 2 is 10, 3 is 15, 4 is 20, 5 is 25, 6 is 30, 7 is 35, and 8 is 40. So we can see that pretty quickly 40 showed up as the lowest common multiple or the least common multiple, so that becomes our least common denominator. So now what we're going to do is we're going to rewrite all three of these fractions using 40 as the denominator. So I've got -3/5. I need to rewrite that as something out of 40. So we ask ourselves, what would we multiply 5 by to get 40? Well, we'd have to multiply it by 8. So we multiply top and bottom by 8, and -3 times 8 is -24. So we have -24 40ths so far. Next up, we have -5/8. We want to rewrite that as something out of 40. So what would we multiply 8 by to get 40? Well, we'd have to multiply it by 5. So I want to multiply top and bottom by 5. So -5 times 5 is -25. So next we have -25 40ths. And then finally, we have -7/10. We want to rewrite that as something out of 40. So what would we multiply 10 by to get 40? Well, we would have to multiply 10 by 4. So top and bottom by 4. So -7 times 4 is -28. So we have -28 40ths. So sometimes when you're dealing with negative numbers, if you can kind of envision them on a number line, it can be helpful. So let's say we have 0 here. Let's go 5, 10, 15, 20. Let me extend this a little bit. So let's say we have 0, 5, 10, 15, 20, 25, 30. So that's -30, -20, -10. And let's see where these numbers fall. Well, we have -24, -25, and -28. So -24 would be right here. -25 would be right there. And -28 would be right there. So that's -28, -25, -24. And remember, the rule is if you're on the left-hand side of 0, the closer you are to 0, the bigger the number is. The further away from 0, the smaller the number is. So in this case, -28 is the smallest. So I'm going to write that with a 1. Negative 25 is next smallest, and negative 24 happens to be the biggest. So if we were going to put these fractions in order, they're actually in the reverse order that they should be. So the smallest was negative 28/40, which lines up with negative 7/10. Next smallest was negative 25/40, which lines up with negative 5/8. And then finally, the biggest was negative 24/40, which lines up with negative 3/5. So there you have those numbers in order, smallest to largest. So again, it's a process. You have to find the LCD in equivalent forms, and then you just order them based on their numerators.